Hi everybody, this is Tor Storley and I am back with another video. In this video, we're going to take a look at how you can build a RAG2SQL. You could say a large language model 2SQL as well, I guess. In any event, we're going to be looking at how to use some framework that is set up and to make our lives easier so we can take advantage of it with its own built-in vector database for embeddings. And we're also going to be using DuckDB as the back end. And we're going to use a specific database called TPC-H, which is a benchmark test database that is being used by a lot of large companies. So we're going to basically use a fairly large one, millions of records in different tables. And we're going to try to construct some queries. We're going to try to train this vector database, and we're going to use DuckDB as a backend. We will be working with VS Code. We will be importing Python libraries in the form of the Vanna AI library and some other installs we're going to need in order for this to work. So the first thing I want to do is introduce you to the DuckDB database that we're going to be using. So let me go in here and let me find that database. So this is the DuckDB database landing page. And what we're going to do, you can go to these extensions here, go to core extensions and scroll down till you see TPC-H. This will tell you that this is an extension to implement the data generator and queries for this benchmark. They describe how this works, and this is how they test different queries. I think there's 22 different queries that are being tested based on this database and based on how the scale, the size of the database is being. You can see there's a lot of big names here. You got the Microsofts of the world, the Oracle of the world, NVIDIA, etc. So there's a lot of support behind this benchmark database. So DuckDB has its own connection to this. And as you can see here, if you don't get it by default when you install DuckDB, you can always run these lines here. So you can see you can run install TPC-H, and then you can load the extension like this. You could generate your own database. And I did this in a previous video, but I didn't do a big one. I did a pretty small one. But you can use this call dbgen SF equals 1. That means the scale factor is 1, and the scale factor represents the size of how much data you want to generate. So if you have a lot of room on your machine, you can make it larger and larger. So you can see there's also these pre-built ones. So instead of trying to create it over the internet and download it as you go, which take a long time, you could also take these already made up databases at different scales. So you can see it goes all the way up to 800 gigabytes here if you do these scale factor 3000 database. If you want a small one, you can do this SF1. I think the one I'm using is 10, so that's about 2.5 gigabytes. A few million records in it. So as you can see here, you can list the queries, you can list expected answers, you can generate schemas like this. You can also run individual queries out of the 22. And we'll look a little bit closer on the queries when we get to it. So for now, what I want to do is, I just want to show you how it will look like when I actually run some of these commands in a DuckDB window. So I'm going to minimize this. I'm going to open my database, which is the TPC-H database. Now, if you want to see what tables are in here, I can just do show tables. And as you can see, it's like an e-commerce style database. So there's customers, there's orders, there's parts, there's suppliers, there's regions and nations. And there's also line items of their orders, so the order items, if you will. So these are the tables. There's like 8 tables, as you can see in this database. And what you can do is you can list all the 22 queries by simply running this query right here. So let's run that. And you can see from this underscore queries. And if you run that, these are the queries, as you can see. Here's the select statements. So this is the text representation of these queries. Another thing you can do too is you can just run an individual query. Let's say I want to run the 5th query here, this one. I can simply do this and refer to the 5th query. And when I run it, you can see here it ran the query and it came back with the results from that query. So there's 22 built-in queries like this. Also, there are tests to see how that query behaves. Because it's made up data, they have to kind of increase the table sizes with more data if you're going to scale this database up for 10 gigabytes, 50 gigabytes, etc. So we can also look at the answers, so like this. And when you look at the answers here, you can see there is a scale factor, as you can see here. And that represents not the pure gigabytes, but it's a scale factor. So this is 0.1%, and then you have all the way up to 1%. So that would be the largest size database. And it will tell you how each query behaves when you actually run this. So let's see what that really means. So let's run one of these queries. And because this is like a function, I'm simply going to extract out the field name from this function. So I'm running query number 2, as you can see. So that's the function. It's a table function, by the way. It returns a table. And as you can see here, this is 0.01 scale factor, and this is the very largest one. So obviously, because you're generating different records, because of you building a size up, you can see here the outcome is going to differ too. So this is the outcome if you're on the lowest database. This is the outcome if you're on the highest database. So you can see it's all the fields are pipe delimited, etc. So yeah, you can actually do that. And just so you can see here, let me just show you this. You can see that this is the one I just ran. And here you can see about the scale factors. There you have it. Now, those queries that I mentioned, they represent different things. So if you look at my screen here, you see here's the 22 queries. And below here, you can see I have a query number 1, and then the select statement, etc. Query number 2, and the select statement, etc. So these are the queries that are being used to test these different scaled databases for benchmarking. And here is a little description of what it does. So here is a pricing summary report, which is the first query. And basically, it will build a summary of revenue by return flag and line status. So they're testing all kinds of stuff. And some of these queries are rather, involved because they have layers to them. They're not just going against one table. You can see here you have many tables. And some of these tables getting large. So you have a lot of joins. So how efficient are these queries going to be? Well, that's what these queries are testing. And they're using all kinds of techniques here. They're using groupings and single selects within, etc. And do a lot of aggregations, as you can see, with case statements. So they do a fair amount of testing here with these queries. I'm not going to go through every query, but you can see here, there's a lot of stuff involved here. If you want more information, go to that website, or go to DuckDB first, and then link over to that other website I just showed you, and you can read up on it in more detail. So in other words, you can go here and try to figure this out for yourself if you're interested. But we're going to be using this database, and I think the one I'm using is going to be the 10. It's about 2.5 gig. This is query number 4. And what is query number 4 saying? Well, number 4 is order priority checking query. So it will count the orders by priority where line items were committed late. So as you can see from my notebook here, you can see this is number 4. That's this one right here, number 4. So let's run that and see what it produces. So let me run that. And here it is. And it ran over a lot of data. And once we get into part 2, and when we go into the Vanna and all the code and the Python code, we're going to do some counts on these tables so you get an understanding of how large some of these tables are. So it runs very fast. It's a C++ based database, and of course that is pretty fast. It's really smoking, really. I haven't put any indexes, anything on here. I don't even know if there is any indexes on this database. But DuckDB has the tendency to create his own helper indexes on data. So I don't know what's happening behind the scenes here. But the speed is quite impressive just looking at this query here. You see there's a group by class. So obviously that takes time. And an order is also going to take some time. So, but it's very fast, and I'm very impressed with it. So let's pick another query maybe. Just go down the list here so you get a sample of what's there. Let me find one that is fairly large. So this one here, for example, let me clean this out and paste that in. So here you can see, select this key and add up the supplier cost plus the quantity available times the quantity available as value from these three tables here. And then you have the where clause here. Going against Germany, you group it by the part key, and here you have a halving statement. So it has its own little select statements here, as you can see. So it has a scale or function right here that runs within here. So let's see how fast this runs. It's pretty much right away, although it produced 0 rows. So I'm not quite sure why it did that. Maybe that's the way it's supposed to be. So as you can see, some of these queries are quite involved. Let's just pick one more maybe. Some of them are pretty short. Some of them are much, much bigger queries. So let's see what this one is. Oh, wow. Are you kidding me? No, this is number 19. It's not that big actually. So let me paste that in. You can see there's the select. You do a sum, so it's an aggregation from these two. The line item is the largest table, I know, and also from the parts table. And you can see there's a lot of where statements here, meaning there's a lot of conditions in here. And there's also an or statements in here. So let's see what this one does. I hit enter and it runs, and it came back with, oh, notice this, how nice this is. Because there's one field here, the new DuckDB will formulate it for you so it looks nicer. But it only does it for like if you have a one return, like one field or whatever. But that's kind of nice. Instead of looking at this huge number here, you can see, hey, it's about 30.10 million records in here. So actually the dollars, I guess, the revenue. Anyways, so you get the idea. So some of those queries are what you're looking at right now. So I like to keep these videos as short as I can because I know just from my own experience that watching videos that are really long is tedious, and even, you know, you don't even know what the quality will be or if it's interesting or not. You know, try to keep these videos a little shorter so you can see if you like them. I think will work better. So I decided to break this project into two parts. This was the first part, and the next part we're going to dig into the VS Code and the actual RAG2SQL application. Now that I introduced you the database, etc., it will be a little easier to follow some of these queries when we see it in the Python project. So I hope you like this video, and if you do, please give me a like and consider subscribing to my channel. It'd be wonderful. And I will see you in part 2 of this video. Thank you.